Under 2.3, we are going to understand functions. And functions is not a new word to you. A function is a mathematical relationship that maps each value of a set of inputs to a single output. The notation fx is used to represent a function of x. Remember, there is input and there is output. There is the domain and there is the range. You're going to see how. The set of possible inputs for a function is called domain, and the set of possible output of a function is called a range. The diagram shown here, of course, we have this diagram which has 3, 7, minus 7, a quarter, and root 2. It is corresponding to another diagram that has 9, 49, 49, 1 over 16, and 2. And you are told that this is corresponding to that. This is corresponding to each other. This is already, of course, you know, 1, 2, 1 mapping. This is 1-to-1 mapping. But it is not 1-to-1 mapping, because already you can see there is a 7 and a negative 7, both of them mapping on 49. So it is many to one mapping. But we are going to see that in details when we get to pure mathematics 3. But anyway, let's see what happens. Of course, this is the function of 3. What happens to 3? It goes through the process of squaring to give us a 9. 7 goes through the process of squaring to give us 49. And all that is actually, everything goes through the process until the f root 2 goes through the process of squaring to give us a 2. The diagram shows how the function fx is equals to, of course you can guess that the function fx is x. Whatever the value of x is supposed to be squared. And that is why all these values squared will give us the value on the right hand side. So this is easily the domain, and this is easily the range. This is the range. It shows the range. This shows the domain. The roots of a function are the values of x for which fx is equals to 0. If you find the value of x that satisfies this statement, then x becomes the root of that particular function. We are going to see this more so in example 8. Let us see what happens in example 8. In example 8, we are told that the function f and g are given by fx is equals to 2x minus 10, and gx is given by x squared minus 9, when all the x are actually real numbers. So find the values of f5 and g10. Let us see. What is f5 for that matter? What is f5? The function of 5. That means 5 has to go through this process, which means it has to be the x now, 2 times 5 minus 10, and you can clearly see that f5 is 10 minus 10, which is a 0. But what is g10? What is g10? Let's see. g10 has to go through this process. 10 has to go through this process. That means 10 squared minus 9. And of course, that is 100 minus 9, giving us 91. And then part B, that was part A. Part B of the same is asking us, find the value of x for which fx is equals to gx. Find the value of x for which fx is equals to gx. it goes without saying that fx is represented by 2x minus 10 and gx is represented by x squared minus 9. So basically this statement means that. And you can see, if you look at it closely, it is a quadratic equation, and we can only help it be by writing it as in terms of x squared minus 2x minus 9 plus 10, meaning plus 1 is equals to 0. And as you can see, what we are supposed to talk of is, if you factorize this, two numbers you multiply, they give us, there is a b and ac. Our b is minus 2, our ac is 1, and clearly this is minus 1 plus minus 1, and minus 1 times minus 1. So we substitute the middle term, x squared minus x plus 1 is 0. So in the first two terms, x is common, so x minus 1, x minus 1, which means x minus 1 is 0, and because it's one of the same bracket, we don't need to keep repeating it. So our entire value of x is equals to 1. What does this mean? When x is equals to 1, the function fx gives you the same value the function gx will give you. Let's see. F1 is equals to 2 minus 10, which is minus 8. G1 is equals to 1 squared minus 1 minus 9, which is minus 8. You can already see at when x is equals to 1, both functions give you the same value of range. Okay?